Line M is Line M is tangent to the circle. Find the measure of the red angle or arc. Part A. Use the tangent and intersected chord theorem, which says that if a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So the measure of angle 1 equals 1/2 times 240 degrees, which equals 120 degrees. Part B. Using the tangent and intersected chord theorem, the measure of arc KJL equals 2 times 155 degrees, which equals 310 degrees. Find the value of x. Part A. Notice that the chords intersect inside the circle, so use the angles inside the circle theorem. First notice that 180 degrees minus 94 degrees equals 86 degrees. So using the angles inside the circle theorem, 86 degrees equals 1/2 times the quantity 80 degrees plus x degrees. Solving for x gives x equals 92. So the value of x is 92. Part B. Notice that the secant ray AC and the secant ray AE intersect outside the circle. So use the angles outside the circle theorem. Using the angles outside the circle theorem, the measure of angle BAD equals 1/2 times the quantity of the measure of arc CE minus the measure of arc BD. Substituting 35 degrees for the measure of angle BAD, 100 degrees for the measure of arc CE, and x degrees for the measure of arc BD, gives 35 degrees equals 1/2 times the quantity 100 minus x. Multiply each side of the equation by 2 to get 70 equals 100 minus x, or x equals 30. So the value of x is 30. Find the value of x. Part A. Use the circumscribed angle theorem to find the measure of angle QSP. By the circumscribed angle theorem, the measure of angle QSP equals 180 degrees minus the measure of angle QRP. Because the measure of angle QSP is x degrees and the measure of angle QRP is 124 degrees, x degrees equals 180 degrees minus 124 degrees, or x equals 56. So the value of x is 56. Part B. Use the measure of an inscribed angle theorem and the circumscribed angle theorem to find the measure of angle ACB. By the measure of an inscribed angle theorem, the measure of angle ACB equals 1/2 times the measure of arc AB. By the definition of minor arc, the measure of angle ACB equals 1/2 times the measure of angle AOB. Using the circumscribed angle theorem, the measure of angle ACB equals 1/2 times the quantity 180 degrees minus the measure of angle ADB. Because the measure of angle ADB is 42 degrees, the measure of angle ACB equals 1/2 times the quantity 180 degrees minus 42 degrees. Because the measure of angle ACB is x degrees, the equation simplifies to x equals 69. So the value of x is 69. The northern lights are bright flashes of colored light between 50 and 200 miles above Earth. A flash occurs 100 miles above Earth at point C. Find the measure of arc BD, the portion of Earth from which the flash is visible. Because segment CB and segment CD are tangents, segment CB is perpendicular to segment AB and segment CD is perpendicular to segment AD by the tangent line to circle theorem. Also, segment BC is congruent to segment DC by the external tangent congruence theorem, and segment CA is congruent to segment CA by the reflexive property of congruence. So triangle ABC is congruent to triangle ADC by the hypotenuse leg congruence theorem. Because corresponding parts of congruent triangles are congruent, angle BCA is congruent to angle DCA. Solving right triangle CBA, you can find that the measure of angle BCA equals the inverse sine of the quantity 4,000 divided by 4,100, which is approximately 77 3/10 degrees. So the measure of angle BCD is approximately 2 times 77 3/10 degrees, which is approximately 155 degrees. Using the circumscribed angle theorem, the measure of angle BCD equals 180 degrees minus the measure of angle BAD. By the definition of minor arc, the measure of angle BCD equals 180 degrees minus the measure of arc BD. Because the measure of angle BCD is approximately 155 degrees, 155 degrees is approximately 180 degrees minus the measure of arc BD. Solving for the measure of arc BD gives 25 degrees as approximately the measure of arc BD. So the measure of the arc from which the flash is visible is about 25 degrees.